Hello and welcome to this short booster session on hot desert systems. I'm just going to talk through kind of the main definitions that we have within desert systems. Desertification, because that's obviously in the A-level specification, and the key case studies to the California Act, and just give you kind of general introduction to deserts. So deserts in Aeolian sensors are the colours on this map that are brown and yellow. So brown is our semi-arid desert and the yellow is our arid desert. The pale green and greeny colours are temperate climates, and the grey colours on the map are to do with the cold deserts, so the glacial areas. So how do we actually define a desert? Well, there are many classifications for deserts because there are lots and lots of deserts within the world. Obviously, we have our glacial deserts and our hot, arid kind of Sahara desert. When you think of desert, think of sand type thing. And because we have many classifications, many desert types, it means we have many classifications of deserts, which rely on rainfall, temperature, humidity, the amount of clouds you get, everything. Meigs in 1953 divided deserts into three categories based on arid, semi-arid, and extremely arid, which is basically just based on the amount of precipitation that we get. And that's the most used or most widely used definition of a desert. It's also worth noting, not only do we have our sandy deserts, which we're used to, glacial deserts, which comes under the classification of deserts, but we also get a thing called rocky deserts as well. So really large barren areas that are just full of rocks and actually very rarely sandy, but they will fall into that desert category as well. So in terms of arid, semi-arid and extremely arid, how do we actually break them down? Well, we break them down based on the amount of precipitation. So a semi-arid desert has somewhere between 250 and 500 millimeters per year. An arid desert has somewhere between 250, has less than 250 millimeters per year. And if you're extremely arid, you're basically 12 consecutive months without rainfall. And the images on the screen just give us examples of the different deserts that we have. So there's a semi-arid Thar desert in Rajasthan, India. You've got the arid, so Death Valley, California, Nevada desert. And then for semi-arid, we've got Badwater Basin, which is California, Nevada in the USA. And you can see on the images like kind of the differences in the geomorphology of them. So semi-arid deserts, yes, we have sand dunes, but we also have lots of vegetation. We have people living in the areas. We have farms going on. Within your arid desert, it tends to just be very sandy, very Aeolian dominated processes. With your extremely arid, you're looking at basically evaporation, and therefore evaporation minerals and evaporation processes that are dominantly occurring. So when we think of a hot system, we tend to think of the sand desert, so mostly the semi-arid or arid deserts. So if we're looking at the geomorphology of an Aeolian system or a desert system, we're looking at basically the geomorphology of a dune. So on the screen we can see we've got a nice dune and we can see all the labels. The main features of a dune are the Stoss slope, so the really shallow slope that is in the direction or kind of upwind direction as your sediment goes up that slope. You then have your lee slope, which is the steeper slope. So you get kind of a lopsided triangle, as it were, in the shape to create that nice dune shape. So that's your Stoss slope and your lee slope. And where the two meet is our dune crest. Within the Stoss slope, we can clearly see on this image, we've got some really nice rippling occurring. And within the lee slope, we have lots and lots of different terminologies that can be used. So you've got the lee slope, which is kind of this really steep bit. Where it starts to shallow off, this is what's known as the dune plinth. The cornice is the very, very top section where your sand drops down from. And the toe is basically where your sand will deposit at the bottom. The whole section, the lee slope, the cornice, the dune plinth and the toe all form this slip face. And then between each dune, we get what's known as the interdune. To give you some idea of migration of the dune system, currently in the Sahara Desert, dunes are moving around 10 centimeters per year. In terms of sediment types, these are the different types that we get. We basically get anodized sediment, looks like millet seeds. It's all kind of fine to medium grained, it's well rounded, and it's generally kind of moderately to low spherical, the grains, so kind of how circular they are. And then with in the dune or the interdune sections, we tend to have areas that are a little bit muddy if we've had some water in that desert. And when we get obviously these really beautiful desiccation cracks, so we can start to see where the evaporation's taken place and sucking the water out of our system. In terms of sediment transport, we get suspended loads, so that's basically where your sediments are really fine and they're actually carried in suspension. So they're carried within the wind, so they're not actually transported along the ground, they're within the atmosphere. You get your saltation, so where the sediments bounce along the ground, and you need that turbulent flow all the time, so that the air needs to be constantly moving. We get reptation. Reptation is where you have a larger class that's not moving even though it's windy, but then will move when it's hit by another particle. And then you get creeping or rolling, which is basically very large particles that move very slowly, and they move basically just by turning on their axes, and it's generally the longest axes that they tend to turn on. In terms of erosion within deserts, most of the erosion is mechanical, and that is done through that suspension of that fine sediment. So it's that fine sediment that is within the suspension, so within the airflow, the wind flow, and it hits the rock outcrops and will slowly erode them away. The reason why on the left of the diagram, this smaller kind of mushroom-shaped bit of sandstone rock, the reason why it's mushroom shaped is because we have the saltation at the bottom as well, and that saltation will hit the rock and will slowly erode away at that rock. Really classical examples of mechanical erosion are the arches of Arches National Park, and we can see that on the image here on the right hand side. Some classical erosional landforms from the desert systems, our hot desert systems, are ventifracs. So that's this image at the top here. And we can see on this image you've got two really nice smooth surfaces, and this is what's known as a Zweikanter, basically two smooth surfaces. If you can get three smooth surfaces on this, it will become what's known as a Dreikanter. If these are left long enough in one place, it will actually tell you the dominant wind direction, because what happens is they form in the shape, the triangle forms kind of towards where the wind is coming from. So if we look at this top image here, the wind is kind of coming from behind the screen to out of the screen. That makes sense. Yardangs, this is quite a famous yardang down here. We can see the shape of it. It almost looks like a donkey or a dog kind of sat down, kind of face up. So they're basically really irregular shapes of sand that are within the kind of prevailing wind direction. So it's quite narrow, which suggests that the wind is going kind of across the screen in this case. Okay. And the kind of last process I'm going to talk about is deflation. So deflation is basically the act of something being deflated. So if we think of a bouncy castle, and we think when it's blown up, it's really big, and then we take all the air out of that bouncy castle, it deflates down and becomes a lot smaller. And that basically happens in our desert systems. We have areas that are full of sand with lots of big clasts, and slowly over time, the process of winnowing occurs. Winnowing is where we take the finer grains away through wind. So wind will physically pick those finer grain materials up and take them away. And we can see that happening throughout this diagram. And what happens in the end is we end up with this desert pavement. And that's where all the coarser material sits on top. This process is really typical in your arid and extremely arid deserts. Okay, so desertification is basically where humans are impacting on the state of the deserts. And there's lots and lots of things that are occurring due to the human life and what we're doing to the desert systems. And there's a whole list on the screen there. So with high temperatures due to climate change, obviously, is increasing the amount of drought and number of wildfires. Irrigation of the plant systems, which increases salt levels, which means the natural ecosystems are becoming out of balance. Lots of grazing occurs because of livestock. Off-road vehicles can be used completely irresponsibly. Lots of mining occurs, which obviously destroys topsoils, it destroys the water table, it contaminates our water tables. You get lots of military kind of action going on, which obviously contamination of the water sources again from weapons testing. Sorry, oil and gas production, which again is really disruptive to the sensitive habitats that we have, and we also get mass nuclear waste dumping. In the Yukon Mountains in the US, there's around 90 kilometers worth of tunnels which is actually currently holding nuclear waste, and that's within one of our deserts. So we're obviously highly impacting our deserts. So what are we kind of trying to do to fix that? Well, communities that live in the desert areas are trying to effectively use the existing water resources to try and control the salinization, to try and decontaminate those waters and just generally improve their lives and the lands around them. There have been roads that have been kind of put into the deserts so that it's clear where those off-roading kind of areas are. And we can kind of see that on this photograph, the second one down on the right. Artificial grooves are starting to be dug, so we've actually retrained rainfall and trap all the wind-blown seeds so that you can actually get kind of almost farming naturally occurs because in the natural process of wind moving seeds around. But if you dig your grooves, the seed gets stuck in their grooves and then your plants can grow quite nicely. It's about education, so there's lots of education going on around the Sahara Desert to the kind of the local populations of that desert system in order to try and help them fully understand what's going on. In Nigeria actually holds 150 of the 200 adexes, and that's the animal at the top here, this white animal with the horns. So what they've done is they've basically designated an area that is totally protected for biodiversity conservation, and that allows for not only the ecosystem to grow, but also allows for these adexes to continue living and continue their livelihoods. And then basically it's always looking at more training and more funding and the interaction within Africa in order to develop new approaches that will really, really help them in terms of farming, but also just help kind of the world naturally get used to these hot desert areas. And there's a really, really good web link that's there from Nature that kind of just introduces you to all of these kind of different concepts within land conservation and deserts. And then I've just got a really good little case study, which is the California Desert Protection Act. And that Protection Act was put in place basically to preserve the scenic, geological and wildlife values, to perpetuate diverse ecosystems and to protect and preserve historical and cultural values, and to provide opportunities for outdoor recreation. And that outdoor recreation is actually kind of limited and you have to have permits to go to certain areas. But because they brought this Protection Act in, since then they've actually had an increase in in the number of desert tortoises. And there's around 25 species that are really wild / endangered that live within the California desert, hence why they've brought this act in to try and help those species continue to live. There's lots of petroglyphs from Native Americans and ancient sites within these areas that, again, this Desert Protection Act protects those sites. And there's lots of lava flows, volcano craters. Again, this protection really protects those sites. So it's kind of given it the status to be protected. And then in terms of just the amount of plants within the California desert, you've got around 300 desert plant species that are actually threatened or totally endangered. So this Protection Act is allowing for all of those things to continue naturally. Thank you for listening.